Okay, good day, grade 11s. I trust that you are well. Today we are going to look at a very exciting part of trigonometry, which is the sine rule, the cosine rule, and lastly, the area rule. Okay, so let me just quickly introduce you to each rule, and thereafter we will look at examples. Now, for each rule, the sine rule, the cos rule, and the area rule, you need to know how to derive these rules, right? So you can either use an acute angle triangle, that's a triangle with all three interior angles that are acute angles, or you could use an obtuse angle triangle, and that's basically a triangle with one interior angle that is obtuse, that is an obtuse angle. So let's first start off with the sine rule. Now, why do we need the sine and the area rule? We need them to find unknown sides or to find unknown angles. So let me just quickly just give you an overview of the sine rule, right? So if we want to find an unknown side, we have a triangle, right? It can be any triangle. Let's call it triangle ABC. Okay. So what I like to do first, before I tackle the question, is that I like to label the sides according to variables. Remember, variables are not capital letters; they small caps. So opposite to angle A would be side A. And I know what you're thinking. Side A is basically length BC, and that's correct, right? That's the variable. Length variable A is BC in my specific example. So I'm going to say let BC be equal to A and let AB be equal to small cap C. I'm just going to write a small cap C like that. So that is the length of AB. And the length of AC is small caps or lowercase b, the variable b. Because remember, variables are always small caps. So now you probably asking, what is the sine rule? So to find unknown sides, let's say I want to find side A. I'm going to first start off with my unknown, which is A, over sine of the angle, which is angle A. It's equal to B over sine of the angle, which is equal to small cap C over sine of the angle. And that is how I find unknown sides. I always start off with the sides, the variables first. But now it is also true. I want you to think about this because maths is all about a thought experiment. Let's do a thought experiment in the side right here, right? If I have a half, right, we all agree that a half is the same thing as 2 over 4 because 2 over 4, it's an equivalent fraction, right? We did equivalent fractions in primary school and in grade 8 and in grade 9, right? We're quite tired of it by this point, but it's quite important, right? A half, 2 over 4 when simplified to its simplest form, it's 1 over 2. The highest common factor between 2 and 4 is 2, so 2 goes into 2 one time and 2 goes into 4 two times, right? That's quite simple. Now, what if I raise the left-hand side by -1? Whatever I do to the left-hand side, I have to do to the right-hand side as well. So I raise both sides by the exponent of -1. Now what happens? It's going to basically get the reciprocal of this fraction. It's going to be 2 over 1. It's equal to 4 over 2. And that is true. 2 over 1 is 2. And 4 divided by 2 is 2 as well. So 2 is equal to 2. Now, by that logic, if I raise each expression by the power of -1, what will we get? We will get sine A over A is equal to sine B over B, which is equal to sine, there we get that right, which is sine C all over variable C. Now, that is true if, of course, the denominators are not 0. And how the denominators cannot be 0? Why? It's a triangle. You can't have one interior angle uh, that's 0 there as well. But of course, sine of an angle could possibly be 0, so just be careful um, of that as well. I think that's the only exception. But in terms of the sides, no side of the triangle can be 0 units, right? It has to be some, even if it's a very tiny triangle, it can be 0.1 units. or 0.001 unit if you zoom in into a very small triangle. So that's basically the sine rule. And so the sine rule helps us to find unknown angles and unknown sides. Now you probably asked it, how does this help me find an unknown angle? Well, last year we learned about arc sine. Shift sign in your calculator can help you find that angle, right? Of course, depending on whether it is an acute or an obtuse angle. But we're going to do a couple of examples on this, so do not stress at all. Right, okay, good. So moving on from there, let's quickly look at, right? Let's quickly look at the cosine rule, right? I want to do the area rule last because that's how I teach it in class. I first look at the sine rule, then we looked at the cosine rule. Now, which trig ratio do you think the cosine rule involves? So if you said sine and cos, that's not correct. It's called the cosine rule, so it involves cos. We know what cos is. Cos is adjacent over the hypotenuse in a right angle triangle. But again, the sine rule and the area rule helps us find unknown sides and angles in any triangle. It does not have to be a right angle triangle. Yes, it can work in a right angle triangle, but it does not have to be a right angle triangle. So let's look at an example of this, right? Let's say again we have a triangle. Now, the cosine rule works when we are given the two sides and we have the included angle. So let's call this B. Let's call this side A because it's opposite to A. Let's call this side B because it's opposite to B. And let's call this side C. So we give an angle C, right? Angle C could be whatever angle this is, right? Maybe it's 20 degrees, 30 degrees, and whatever that case. It could even be, if this was an obtuse angle triangle, it could be an obtuse angle as well. So you're probably wondering, so what does the cosine rule actually say? Again, the cosine rule helps us find unknown angles, or it could be unknown sides. So let's say we were given the length of AB, we could actually find angle C, but let's not jump the gun there. Let me just quickly show you what is the cosine rule. So the cosine rule basically states that if we want to find this length here, which is side C, I could say C squared is equal to A squared plus B squared minus 2AB cos angle C. Whether you put this angle sign or not doesn't really matter. And using that logic as well, we could also prove that A squared is equal to B squared plus C squared minus 2BC cos angle A. And all again, using that logic, we can also say that B squared, small caps B, that means the side AC all squared, is equal to A squared plus C squared minus 2AC cos angle B, right? And again, it's extremely imperative that you learn how to derive, which we did in class as well, both for the acute angle triangle and the obtuse angle triangle as well. Now that leads me to the last rule before we look at the examples, and we're going to start off with the area rule as well because it's quite interesting, right? Let's quickly look at the area rule before we start looking at examples. Again, I think it's extremely important that we know how to derive this because maths is not about memorization, it's about application. So I don't expect you to memorize any specific steps. Of course, you should know a procedure on how to tackle a question. That's not the same thing as memorizing something, right? But back to the point, we are on the area rule, and of course, we have to calculate area. So again, let's say we have a triangle, right? We have a triangle. Let's call it triangle ABC. And again, whether you are working with the sine rule or the cosine rule or the area rule, my step number one is always to, or my procedure to tackle the question is to label the sides according to variables. The side AB, or rather BC, it's opposite to angle A, so I'm going to call it variable A. This side AB is opposite to angle C, so I'm going to call it C. And lastly, AC is opposite to angle B, so I'm going to call it small caps B, right? So to calculate the area of this triangle, right, Again, you just need one given side. So I could say that the area of this triangle is half AB sine angle C, or you could calculate if we were given angle C, and if so basically angle C, we agree it's the included angle. When I say included angle, it's basically the angle that's between two given sides. So angle C is basically sandwiched in between side A and side B. Or we can say that the area is equal to half AC sine angle B, or we can say that the area is equal to half, and let me get this right, BC sine angle A. And again, what do you notice about angle A? Angle A is the included angle between angle B and angle C. Excuse me. Now, let's look at an example of this. So I got a couple of questions here. I'm just going to pull up. Okay, let me get this out of the way. No, okay, let me get this out. Right, okay. Right, okay. As long as that's out of the way, now let's see if we can actually do this. Okay, that did not work. Okay, let's try to figure this out. I have the question here. What I want to do is I want to copy it. Yeah, right. Okay, let's see. Okay, this is not working. Right, okay. Okay, let's do it the old-fashioned way. Copy and the paste button is not there. Okay, let's do this. It's a much longer process, but I want to get the question. You can see the question is here. Right, now let's see. There we are. Right, okay. So this is the question. Much longer process to get to the question, but nevertheless, this is what I have, right? We have to find the area. We have to find the area of triangle ABC. Now, what is step number one? If you have forgotten what I said, step number one is to label the sides. So let's call side BC A. Let's call AB variable C, and let's call AC, the length of AC, variable B, right? So what is my included angle? It's going to be 50 degrees, which is angle B. By the way, what's the length of angle B or side B? That is, it's not an angle, it's a length. What's the length of variable B? The length will be 7 units. Right? They did not specify whether it was in meters or centimeters or millimeters, so we're just going to use units. Okay. What type of triangle is this, by the way? This is what we call an isosceles triangle, right? Because we have two equal sides. AB is equal to AC, and also, let me get this right, the angles that are opposite the equal sides are equal. That means angle B would be equal to angle C. It's opposite and equal sides. So this angle here, just for curiosity's sake, is 50 degrees. Just for interest's sake, how will we find this angle C? Yes, we will use the sum of angles of a triangle, which of course we know it to be 180 degrees, and we can find the third angle of the triangle. But nevertheless, back to our point, let's just do our job and find the area. So we have these two sides. Actually, we do need angle C now that I have angle A, and now that I'm looking at it. So what are we required to do? We're required to find the area of triangle ABC. First things first, I'm going to say that AC is equal to 7 units. Why? That is technically given to me. How do I know it's given? Because it's marked on the diagram. And I'm going to say that angle C is equal to 50 degrees because they're angles in an isosceles triangle. Let me get this right. It's actually um, angles opposite equal sides. Angles opposite equal sides. I know they're very particular on the reasoning, especially um, in grade 11 and 12, but it's basically angles in an isosceles triangle, right? Angles in an isosceles triangle because it's an isosceles triangle, and the angles that are opposite the equal sides in an isosceles triangle is equal. So I cannot disagree with that. And lastly, if you're going to find angle A, I'm going to use the sum of angles of triangle. So 180 degrees minus angle B, which was 50 degrees, minus angle C, which is also 50 degrees. My reason is angles in triangle or sum of angles of triangle, right? Whenever it comes to finding unknown angles, it's always important geometry to put a reason there as well. So just bear that in mind. It's also very, very important. So angle A is 80 degrees. Okay. Now that I know what angle A is, which is 80 degrees, angle A is what we call the included angle between side B and side C. So which formula will I use for area? I'm going to say that area of triangle ABC is equal to half. Do not forget about the half. For some reason, learners always forget the half. And I think I was in university as well, and we wrote a paper, and I also forgot about that half, and that still haunts me to this day. So don't forget about the half in the formula. So it's half BC sine angle A. So it's going to be half B, which is 7 units, times 7 units sine 80 degrees. Always use your calculator to do this, and make sure your calculator is set on degrees and not rads or grads, or else your answer will be incorrect. So let's just punch in everything in your calculator and it should give you the correct answer, right? Let's round off. Oh, it says 2 decimal places, so that's great. So it's going to be 24.127. So of course the third digit is 7, it's greater, it's 5 or more, so the second digit will be rounded up to 3. And I'm going to say squared units, so units squared units, because it's area, right? If it was meters, it would be meters squared. If it was centimeters, it would be centimeters squared, etc. So that is the question that we have. Right, I had another question on area, but I think it's fine. We can move on to our next. Again, I don't want to waste time. I know it wouldn't work if I just copy and paste it directly, so I'm going to do this long story and quickly get it uh, into our work. Okay, so that should now. Okay, let's clear the screen. Now let's look at an example on the sine rule. Now again, in your exam, they're not going to say apply the sine rule. You need to look at the question carefully and see what you can apply, the cosine rule or the sine. Of course, area, you have to use the area rule, but you can't use the sine. Or maybe you could use the sine and cosine rule to help you find unknown angles that will help you eventually use the area rule. So very interesting as well. Right? I should have enlarged this a bit, but it's fine. I hope you can see it. So it reads, given triangle. Now, normally they'll just give you the question and you have to draw a sketch on yourself. But just to save some time in this video, I decided to include the sketch here as well. But bear in mind, they may not always give you the triangle. So you need to read carefully, right? And next we are going to do something very interesting called the ambiguous case, which is very exciting as well. So I cannot wait to explain that. But this reads, given triangle TRS with angle SR, STR, this angle is equal to 55 degrees. TR is 30 what? 30 units because they do not specify. And RS, an angle RST is 40 degrees. Determine the length of this guy here, which is RS, determine the length of ST, and lastly determine angle TRS. Okay, great. TRS is quite simple to actually get. You can use the sum of angles of triangle, or you can also use the sine rule as well. But I think sum of angles of triangle, we can all agree, is much easier, right? So step number one, what do we do? Right? Step number one is to label our sides according to variables. I think this is the easiest step, right? So I'm going to call this side R. I'm going to call this small letter s. I'm going to call this small caps T. So let's first start off by finding R RS, right? We can find RS. So we always start off with our unknown variable. We're going to say T over sine T, sine angle T is equal to, then we use what we are given. We are given the length of S, and we are given the angle of S as well, angle S. So we're going to say S over sine S, right? T, we do not know what T is, so T over sine T, we know what angle T is, 55 degrees. Remember, whenever I mark learners' books and their tests, I always notice you get the degree sign. That is basically our units of measuring the angle. We're using degrees, so it's very important that you included that symbol for degrees there as well. That's equal to S, which is 30 units over sine of 40 degrees. Now what we need to do is we need to find the size of t, so we need to get rid of this denominator. So how do I get rid of the denominator? The opposite of division is multiplication. I need to multiply both sides by sine 55 degrees. Right, of course, the sine 55 degrees will divide off. I'm left with t is equal to all of this. And of course, you can take your calculator. Make sure again it's on degrees. I'm going to say 30 over sine 40 degrees times sine 55 degrees, and that is equal to 38.23 units. I'm going to round up to 2 decimal places. Again, it didn't specify, but if you look in the front page of your tests or exams, there will be an instruction to state how much you should round up, whether it's to 1 decimal place or 2 decimal place. So just be careful about that. Next, let's look at side ST. So again, we're looking at side R. So I always like to imagine, just in case I got T incorrect, and of course I'm rounding off, so it's not going to give me an accurate amount. Let's use what we have. So before we find ST, let's find this angle here, R, because we need it. It's the angle that's opposite to the side. So how do I find angle R? I'm going to say angle R is equal to 180 degrees minus angle T, which is 55 degrees, minus angle S, which is 40 degrees. My reason is sum of angles of triangles or interior angles of triangle. That's fine. And what is that? That will be 180 degrees minus 55 degrees minus 40 degrees, and I have 85 degrees, right? And now I can find R. I'm going to say R over sine R is equal to, now we use again what we are given. We were given S. I'm not going to use T because we just calculated T in case it's incorrect, and more importantly, we rounded off T. So always use what you were actually given in the question. I think that's the safer option between the two, right? And we have R over, sorry, oh yes, we have R over sine R, we just calculated that to be 85 degrees. It's equal to 30 over sine 40 degrees. So R is equal to 30 over sine 40 degrees times sine 85 degrees. I basically multiply both sides of the equation by sine 85 degrees. Let's use our calculator. I have 30 over sine 40 degrees times sine 85 degrees, and I have 46.49 degrees. Not degrees, sorry. We find it in an unknown side, so that will be units. And by the way, something that I should have mentioned as well. We said T, but what is T? exactly. T is the length, RS. So RS is equal to 38.23 units. And lastly, variable R, which is ST, is equal to 46.49 units. Okay, and that basically answers this question. Okay, now we have something that is called the ambiguous case, and this is why it's very important to read to understand. And whenever I do examples with you, right, we're not memorizing the examples, we're understanding the conceptual understanding. We're having an idea of what exactly we are trying to achieve. In this case, we are trying to achieve finding unknown sides and angles, right? So let me just go down here, right? This is the question, the small question here. Again, I need to get this. Okay, right. Okay, this is the question that we have. Let me try to enlarge it so that you can see it nicely, right? Right. So the question reads, in triangle ABC, right, AB is 82 units, BC is 65 units, and angle A is 50 degrees. We need to draw, firstly, we need to draw a diagram of what we're dealing with. We need to draw a triangle ABC, and we need to find angle C, and we need to correct to one decimal place. So the first thing we're going to do is we're going to draw a triangle. All right, let's draw a triangle like this. So according to this information, we have triangle ABC. So that's what I'm going to write down here. I have triangle ABC, right? Everything seems quite fine now. There's no problems. AB is basically length 82 units. That's easy enough. BC is 65 units. That's also fine. And angle A is 50 degrees. Okay, so what is so complicated about this? Why is it so ambiguous? We just need to find angle C. Easy, right? We can use the sine rule and we can easily find angle C. There's no problem at all. However, although this is correct, another student could come up to me and say, sir, I interpreted this triangle completely different, right? I drew my triangle like this, right? I said this was angle A, this was angle B, and this was angle C. And how I drew my triangle, I said that this was 82 units, and BC was 65 units, as they stated there. And angle A looks like it's an acute triangle. Well, it is an acute angle, which is 50 degrees, and angle C, I interpret it as an obtuse angle. And this is what we call the ambiguous case, because one can interpret this angle C as an acute angle in an acute angle triangle, whereas another person will interpret this as an obtuse angle. Now you might ask me, right, how do I know when the ambiguous case is at play? When you're given, firstly, you'll be asked to find an angle, and the angle that you have to find, you'll be given two sides. If the angle you are required to find is opposite to the larger given side. Let me repeat that. When the angle you're required to find is opposite to the larger of the two given sides, that is when we have an ambiguous case. That means angle C could be an acute angle, or angle C, in this case I'm going to name it C prime if you're looking at another triangle, could actually be an obtuse angle in an obtuse angle triangle. So which one is correct? Mathematically, both are correct. That is why it's called the ambiguous case. So let's first look at it in terms of an acute angle. So I'm going to try to find angle C. So to find angle C, I'm going to use the unknown first. So sine angle C over small c, right? So again, my step number one is always to label the triangle. So this is side C, it's opposite to angle C. this is variable B, it's opposite to angle B, and this is variable A, it's opposite to angle A, right? It's equal to, now we're going to use what is given. What was given? What was given was A and angle A. So we're going to say sine angle A over A. What I don't want to see is people write in this is mathematically correct. If you write sine C over C is equal to A over sine C, that does not make any sense at all. If sine is on the top, sine has to be on the top. If the variable is on the top, then the variable has to be on top as well. So let's calculate angle C. So we're going to say sine angle C over variable C is 82 units is equal to sine A, which is sine 50 degrees over variable A, which is 65 degrees. And now we just basically solve for angle C. So I multiply both sides of the equation by 82. So I have sine angle C is equal to sine 50 degrees over 65 units times 82. So what is sine C equal to? So this will give me a large decimals. Whenever it comes to trig or even financial math, I always try to round off the final answer, right, to 2 decimal places. So it might be quite time consuming, but it will give you a more accurate answer at the end. 45282, right? Then of course in your calculator you say second function sine and you get your value, right? So shift sine of that answer. So my reference angle, be careful, I'm just going to write reference angle is 75.10 degrees. So what is angle C? Angle C is an acute angle, so basically angle C is 75.10 degrees. But now if I look at angle C prime, which angle C could actually be interpreted as, right, in which other quadrant is sine positive? And I know you're busy screaming in front of your screen that sine is positive in the sine quadrant, hence why it's called the sine quadrant, quadrant 2. What's the trig ratio in quadrant 2? 180 degrees minus theta, minus the angle, that acute angle. So angle C prime could be 180 degrees minus the reference angle of 75.10 degrees, which will give you a nice obtuse angle of 104.895, so that will be 90 degrees. That's the size of angle C prime. So that is basically the ambiguous rule, and I think they'll love to trick you with the ambiguous rule there as well. So let's make sure that we cannot get tricked. Right? Once you understand the conceptual understanding, there is no such thing as trick questions. Everything becomes easy, right? And that is what those are the examples. That's basically maths in a nutshell, right? So they can never trick you once you have a good conceptual understanding of the content. For example, something like this. This is regarded as a complex to a problem-solving type question, and we are quite fortunate that this example gave us the diagram as well. So this is the question. This is the last one in the sine rule. Then I'm going to quickly look at the cosine rule. Then we'll wrap up this lesson accordingly. Right? It's a bit blurry. Apologies, but I'll read it out to you as well. Right? So it reads: there is a coastline with two lighthouses, one on either side of the beach. Right? The two lighthouses are 0.67 kilometers apart. Okay, so basically there's one lighthouse here. Okay, let's get that right. There's one lighthouse here, there's another lighthouse here, and what's the distance from point A to point B? 0.67 kilometers. Now we're not dealing with units, they gave us the units we are dealing with, it's kilometers, right? And one is exactly due east of the other. So of course, if you're looking at lighthouse A, east of it is lighthouse B. So the lighthouses tell how close a boat is by taking bearings to the boat. Now, what is this word bearings? What does that mean? A bearing is an angle measured clockwise from north, right? So let's say this is north, right? So I have a perpendicular line and I have something else here like ground or something, and I ask you for the bearing. So you start north, then you go clockwise, 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 touching what you need to look at, and that's what's happening here. So this entire angle here, this large reflex angle is 255 degrees. Right? These bearings are shown on the diagram below. Calculate how far the boat is from each lighthouse. So where's the boat? The boat, this is the boat here, right? It's at point C. So very interesting question. Let me actually redraw the triangle. So let's get this out of the way. This question needs some space. Okay, it's a very fun, very interesting question, as you can see. So let's redraw the diagram. I actually thought that would invert quite nicely, but it doesn't. Okay, so nevertheless, we'll have to rely on my hand drawing triangle, which, as you can see, is much better. Okay, but we have triangle ABC, and we know what the length from one lighthouse A to the other point on to the other lighthouse, that's going to be 0.67 kilometers, right? And the thing is, we need to find these interior angles. You agree? We need to know what is angle A, what is this angle here, and yeah, let's get this right. Yeah, I think this pen of mine just stopped working. Let's get this right. Come on. There we are, right? What is this angle? Okay, reconnected. What is this angle A, right? So as we can see, this entire angle is 127 degrees. What I'm going to do now, right, I wish I can zoom in to show you. But the point, okay, where am I? Okay, let's hope that this is the last reconnecting issue, right? Okay, there I am, right. Now, this angle here is 90 degrees. How do I know? It's perpendicular to AB, right? This is north, this is a perpendicular line. So what will the remaining angle be? Yes, the remaining angle, basically you can call it angle BAC, will be equal to 127 degrees minus 90 degrees, because we can see that this is a perpendicular angle. So it's 127 degrees minus 90 degrees, and that will give me 37 degrees. So that what that basically means is that angle A is 37 degrees, right? And let's now look for angle B. So again, this is 90 degrees. So what is this entire angle equal to? This entire angle is 255 degrees plus 90 degrees. So how do we get this remaining amount? What's an angle around a point? Angle in a revolution? 360 degrees. Very interestingly. So I'm going to say that angle ABC is equal to 360 degrees minus 255 degrees plus 90 degrees. And again, angles in a revolution, or angles around a point, angles in revolution, that's equal to, let's use our calculator, 15 degrees. So what I just calculated now was angle B, which is 15 degrees. And I know what you're thinking. You can even calculate the size of angle C if you wish. You could say that angle ACB is equal to 180 degrees minus 37 degrees. I'm not sure if we're going to use it, but nevertheless, it's quite nice to actually have an idea in case we do need to use it. And the reason for that is sum of angles of triangle. So we're going to use the sum of angles of triangles, 180 degrees minus 15 degrees minus 37 degrees, and that will give you 128 degrees. Okay, so as you can see, this is actually an obtuse angle triangle, right? So of course, it's not drawn to scale, so it might look like a normal triangle, but it's not, right? So let's continue with the question. We are required to find, what are we required to find? We have to calculate, that actually should be the first thing that we get in the question. We have to calculate how far the boat is um, from each lighthouse. So basically, we have to calculate the length of AC, how far it is from lighthouse A, and we need to calculate the length of BC, how far it is from lighthouse B. So let's start off with AC. So what I'm going to do is, step number one, let's label our sides according to variables. So let's call this variable B. It's opposite to angle B. Let's call AB variable C. It's opposite to angle C. And let's call BC variable A. So let's calculate it now. So we are going to calculate B. So I'm going to say B over sine angle B is equal to, now let's use what we are given. We are given C. It's going to be opposite to sine angle C. So we have B over sine 15 degrees is equal to C, which is 0.67 over sine 128 degrees. So angle B is equal to 0.67 over sine 128 degrees times sine 15 degrees. That's going to give me, now let's use our calculator, 0.67 over sine 128 degrees times sine 15 degrees. That's going to give me 0.22 kilometers. What did I just calculate now? I just calculated the length of AC, because that is what B is, right? Now from there, let's calculate the length of A, right? We're going to say that A over sine A is equal, I hope you can see this is quite small, but A over sine A over, again, we can use what we've given. Although we know what AC is, let's still use our initial given, which was C over sine C. So we have A over sine 37 degrees is equal to C, which is 0.67 over sine 120 degrees. So let me write it down here. A is equal to 0.67 over sine 128 degrees times sine 37 degrees. So what is the length of A? Let's use our calculator. And we have 0.15 kilometers. Okay, so that is basically the sine rule. Okay. What I want to do is I want to quickly save this. Okay, now that being said, let's quickly move on to the cost rule, and then we'll end up from there. Now the cost rule is also very, very interesting, and I explained what it is in the introduction. And again, the question will not specify, okay, you need to use this rule now. You just need to know your rules quite well. So let's go back to our initial document with the questions. Let's find this question. Yes, so I have two questions that I found from Siobula, which is also quite an interesting textbook and software to use for extra practice as well. I enjoyed, and surprisingly, this was the textbook that I used when I was in school as well. So it was quite useful and very, very nice to use. Okay, now we have to determine the length of QR. So we are given triangle PQR, and we are given the length of PQ, which is 13 centimeters, and we are also given the length of PR, which is 4 centimeters, and we are given angle P. Now, what do we call angle P? Yes, we call it the included angle. It's the included angle to which two sides? To PQ and to PR. A lot of letters I just said, so what's step number one? Right, let's label our sides. So let's call this small, the length 13 centimeters small caps R. Let's call this small caps P. Let's call this small caps Q. So what are we required to find? QR, so I'm going to say P over, I'm so used of the sign, but it's actually P squared is equal to R squared plus Q squared minus 2RQ cos. And because we're finding side P, we're going to use angle P. You don't even have to put this angle sign here because we know we're dealing with angle P. So we have P squared. Now let's substitute. What is R? It's 13 squared plus 4 squared, 4 centimeters all squared minus 2, 13 times 4 cos angle 70 degrees. Right? And at this point here, you just use your calculator and you calculate everything that you need to calculate. So we have 13 squared plus 4 squared minus 2 into 13 times 4 cos 70 degrees. Right, which gives you 149.4299051. Notice I included all decimals, then I square root both sides. And I know what you're thinking, shouldn't it be plus minus a square root? But remember, we're dealing with the length. And if you take a ruler and if you measure something, it's impossible for you to get a negative length. So it's always positive. So I have P is equal to the square root of 149 and the decimal, which is 12 point, now I can round up to 2 decimal places, 12.22 centimeters. And that's my final answer. Right? So that's how you use the cosine rule. Okay. Let's do one more example. So the cosine rule, as we said, very similar to the sine rule, it can help us find unknown sides, but it can also help us find unknown angles as well. And that leads me to the last example for today. So let's quickly look at the last example for today. Oh, that's cool. I didn't know it can even do that, but okay. Nevertheless, but I can't really see the numbers like that. Okay, maybe. Okay, that's fine. Okay, so this is the question that we have. We are given triangle ABC and we are given that the length of AB is 5 units. We are given that the length of AC is 8 units and we are given that the length of BC is 7 units. The thing is we have no angles. What are we required to find? We are required to find this angle here, angle A. Step number one, as with the sine rule, or even to find area, we have to label the triangles. I find it the easiest to do this, right? So we're going to call BC variable A, we're going to call AC variable B, it's opposite to angle B, and we're going to call AC small letter c, and we are required to find A. So what do we need? We need cos A. We need cos angle A, so we can use shift cos and find the angle. So in order to do that, what formula can we use? We're going to say A squared is equal to B squared plus C squared minus 2BC cos angle A. Very, very simple. And now we have A squared. Sorry, do we know what A is? Yes, it's going to be 7 squared is equal to 8 squared, because angle A is now the included angle, plus 5 squared minus 2 times 8 times 5 cos angle A. Then you can use your maths and you can make cos A the subject of the formula. So what I'm going to do is I'm going to take 8 squared to the other side, and I'm left with negative 2 times 8 times 5 cos angle A. Then, of course, I'm going to divide both sides by what was being multiplied to cos A. So what am I left with? I'm left with cos angle A is equal to 7 squared minus 8 squared minus 5 squared all over negative 2, 8 times 5. So cos angle A is equal to all of this. So let's enter that into our calculators. So we have 7 squared minus 8 squared minus 5 squared. That should give you a negative amount, but remember, negative divided by negative is a positive, so it should end up with a positive quotient. Now that gives you a nice half, right? And remember, angle A is an acute angle, so that's quite nice. So we can say basically second function of cos. And of course, you don't even have to use your calculator. Why? Because it looks like a special angle, and that special angle is 60 degrees. So angle A is equal to 60 degrees. Okay. Thank you, grade 11s. I hope this video helps. Remember, practice, practice, practice. Do not stress. Go through one example at a time. Make sure you can recreate the examples I gave you or that I did with you now, and practice as many questions as possible. Okay. Thank you, everyone.